Hi, now it's time to look at more creative ways of using audio signal routing. And we're going to build an FM synthesis thing, frequency modulation. So that's basically taking the output of one oscillator and put it to control the frequency of another oscillator. And we call the modulator oscillator for the modulator and the other one for the carrier. It's a cool way of making sounds that got very popular through the Yamaha DX7 synthesizer, which came when I was a teenager, so I fell in love with it. Anyway, this is how it works. We have a chain that contains one oscillator node and one gain node. And the gain node is just used as a gate to control the sound. So we turn it on when we touch down or click down, and we turn it off when we release the finger or the mouse. This is the carrier oscillator. Okay. Then we have this chain that contains another oscillator, and we have a gain node for that one as well. But that's always actually sounding, even if we can't hear it, and that is because the output is set to #carrier. And that means that if we look for an element with its ID set to carrier and takes the output of the modulator and feed it into the element with the ID set to carrier, which is this one, the detune parameter in web audio. And that's a parameter controlling the frequency of the oscillator. So what I do is I set the sort of basic frequency following the relative x value, and it's mapping its value to MIDI notes between 60 and 72. And then I modulate the frequency all the time with another oscillator, the modulator. And that oscillator is also following the relative x value, but it's mapping its value to MIDI notes between 36 and 48, which is 2 octaves below the carrier. And it's quite a useful sort of range between the carrier and the modulator. But you can play around with it to have different offsets to get different harmonics in the sound. The other important thing is the gain node on the modulator, and that is used to take the output of the oscillator, which normally oscillates between 0 and 1, and we gain it up so it now oscillates between 0 and 200, and that is fed into the detune property, the element detune over here. So the more we gain here, the more sort of power we get from the modulator into the carrier wave. So it's also important to see that I use sine waves in both examples, which is typical for FM synthesis. But you could, of course, use any type of waveform if you want to. This example sounds like this. And if I add more gain to it, go a bit further, or extreme. So one thing you could do is to play around with the modulation and the amount, and as I said, also the distance, the offset between the modulator and the carrier. So if I set this one to 48 to 60, that means that we have 1 octave interval between the two oscillators, and that gives actually quite different sounds. So you can play around with that, and then you can of course use everything we know from the chain. So we could run the carrier oscillator through a backward filter node, for example. So we can add harmonics to the sound and then reduce it with the cut-off low pass filter. So that was the power of the output attribute and the detune element to use two oscillators to modulate each other.